And so waves is the disturbance.
Okay.
Wave is the what? Disturbance that can
carry mass.
That can carry, not mass. It can carry energy.
Oh.
Well, then let's talk about motion. Motion. M-O-T-I. Motion. There are two types of motion, right? Particle. Particle, like car. Wave, like sound, EM wave, right?
Okay.
EM wave. Right. The car can, the motion of car can carry what? Carry mass.
Okay.
And the waves can carry what?
Energy.
Only energy. It cannot carry mass. The wave cannot carry mass. Remember that. Wave cannot carry mass. Wave never carry mass. So what is waves? Waves is a disturbance that carries energy from one location to another location. It never carries the mass. It never carries the mass. There are.
No mass. How can a 0 pound be?
Well, that's different story. That different story. Okay.
Yeah.
The,
so, like, how can a 55 pound baby carry a 180 pound man? It doesn't make sense. So waves can't carry mass because they have no mass.
So today we're going to talk about three types of waves. Okay. There are many types of waves, but three are the main: mechanical waves, electromagnetic, sometimes called EM, standing wave. Does that make sense?
Yeah.
Mechanical waves needs medium. So write down this medium.
Okay.
Like slinky. Have you ever seen slinky?
Yeah, it's like a coil.
Yeah, slinky.
Yeah, I play with those ones. You stretch them out, and because of their elasticness, they will try to go into equilibrium, but they will always bounce, and it's super sad.
So it's not medium, right?
Yeah.
There's no medium. Mechanical wave, there are two types of mechanical wave. Transversal. Longitudinal. Transversal, the particles, okay, when I move a slinky, okay, so the particles moves perpendicular with respect to the motion of the wave.
Oh.
So perpendicular.
What about when you shake a water bottle like this? I see waves.
Well, the water waves is
water waves is also transversal.
It's transversal. Okay, we're gonna get to that in a second. Longitudinal. Longitudinal, the particle moves parallel with respect to the motion of the
Object.
motion of the wave. We are talking about the wave.
Wave.
So parallel. Alright, should I write perpendicular or that sign is fine? Do you are you familiar with this sign?
No.
This called
Perpendicular parallel.
I know my physics.
Okay, good. Alright, now transversal, example of transversal wave is what? Is like water wave.
Water, just like you said.
Mechanical transversal, by the way. Mechanical electromagnetic wave is transversal. Alright? Standing wave can be transversal, can be
Longitudinal.
and can be longitudinal. Alright, transversal wave, alright, is the water wave. Longitudinal wave can be sound wave.
Okay.
Sound wave needs medium, by the way. Sound wave needs medium. So if I say something, if I create a tunnel, and if I remove the ear from the tunnel, if I say something, then the sound wave will not
come on.
That's why.
Sound wave cannot what? Sound wave cannot carry the energy.
That's why in space.
That's why in space nobody can hear you when you talk. You need to have a medium.
Because space is vacuum. What is it?
Vacuum, not vacuum.
Alright, okay.
What's a vacuum?
Alright. So transversal wave. What is the example of transversal wave?
EM waves.
Not EM waves. EM waves is like how many EM waves we saw? Not light. EM waves we saw 7 different type of EM waves. Gamma ray, X-ray, ultraviolet, infrared, microwave,
radio wave,
and visible light.
invisible light.
Okay, so let's say visible light. Visible light.
Oh. Wait,
So lights are two types: visible and invisible.
Okay.
Okay.
I'm confused. You wrote mechanical waves were transversal and longitudinal, but you also split standing waves into transversal and longitudinal.
Yeah, I'll show you how that look. I'll show you how that look like. It's mainly is transversal. I'll show how you look like. All right, now mechanical wave. I'm going to show you mechanical wave. The transversal wave. This is how transversal wave look like. Look like a sine theta.
Perpendicular.
Yeah.
All right, this is look like a sine theta. How many cycles you want me to draw?
3 or 2 cycles.
How many?
2.
Oh.
You sure you want me to draw 2 cycles?
Just 2 cycles.
Yeah, if you're like 2,
I cannot fit. Okay, I fit 2.
Okay.
So 1, 2 cycle. This is what do you want?
Maybe we can say 5 to -5.
-5, 5.
And 10 meters is the
10 meter. Okay.
total distance.
All right. So this is called transversal, right?
Yeah.
This is called crest.
Crest.
Oh, crest.
That's called a trunk.
This is Trump. Not President Trump.
Yeah.
This is trough.
Trough.
Troughs are much better than trunks.
We're not gonna talk that type of thing. No, we're not gonna talk that kind of thing in the classroom. Okay?
So,
No, we're not gonna say that type of thing in the classroom. Okay?
yeah.
Good.
What does trough is any other meaning?
Yeah. Trough means the lowest
The lowest point.
point. This is the highest point. This is called amplitude. This is called
Amplitude.
amplitude. All right. This is crest. This is trough.
Mm-hmm.
Now we're gonna get to that in a second, but this is how what look like. A transversal
Wave.
wave look like, and longitudinal wave look like this.
Parallel.
So, like gamma rays?
So this is called rarefaction,
Rarefaction?
and this is called condensation. Condensation is kind of a crest, and rarefaction is kind of a.
Trough.
All right. So electromagnetic wave is transversal wave, just like look like that.
Okay.
Electromagnetic wave is just like. In fact, I'm going to show you the electromagnetic wave right now. This is how electromagnetic wave look like. This is 3D, right?
Yeah.
Do you understand 3D? X, Y,
Z.
Z, and then you have
That looks like electric field, right?
this is electric field, and this is gonna be what direction you think?
To the left.
To the west or to the east?
To the west.
Good. Good. Alright, so this is
Because
E.
the waves are rotated perpendicularly.
This is? Yeah, good. So E and B are
Perpendicular.
perpendicular to
Each
B.
other.
So what direction is this one you think?
East.
No, south. Okay?
And that's
And this is east. Okay,
East.
good.
it's pointing outside the board.
Okay. And what direction is this?
West.
North.
North.
North and west. Northwest, southeast.
Alright, good. What is the black one? This one.
Electric field.
And this is?
Magnetic.
Alright, so this is also transversal. This is also
Transversal.
transversal. This is electromagnetic
Wave.
waves, and this is mechanical transversal. Mechanical transversal, electromagnetic transversal. Now we're going to talk about standing wave. Does that
Yeah.
make sense?
Uh-huh.
If you have a barrier, do you have a barrier? And if you have the transversal wave, we're going to call it, this is ugly. Alright, this is, we're gonna call it incident. What are you gonna call it?
Incident.
I'm gonna use that same card, incident. Alright, so incident hit the what? Barrier. What does it hit?
Barrier.
And then it will reflect.
Wait.
It will reflect. What it will do?
Reflect.
This is called reflect.
Is this a standing wave?
This is, oh good, this is a standing wave. So this is called node. This is called,
No.
let's write it down, nodes.
NODE.
And if there are nodes, there's gotta be anti-nodes, right?
Oh yeah, antinode.
Oh.
So how many nodes do you
Only
think?
for my
4.
digits.
4 nodes. How many antinodes?
4.
No.
8.
1, 2, 3 antinode. Common misconception. How many? 3. Alright, so what type of, we know that the mechanical transversal is water wave, the mechanical longitudinal is sound wave, the EM waves is the visible light. So then standing wave is what? What type of thing comes to your mind when you see standing wave?
Transversal.
No.
Um.
Guitar, for example.
No.
Guitar. Is that how you spell guitar?
Yeah.
Guitars kind of vibrate. Guitar strings kind of vibrate after you pull them.
Yeah. So guitar creates
And
resonance.
it's also and it's also like a slinky, because a slinky, when you stretch it, it will try to get back to equilibrium.
Right.
But because of its elasticness, it will.
Can you
dance
move over
around.
there? Can you move over there? You're blocking the camera. Can you move over there? So now, guitar can create what? Resonance. What is resonance? When you allow something to vibrate, it natural frequency, then it creates the resonance. Is this a resonance?
No.
This is a noise.
Let me, I'm going to try.
Is this a resonance?
Yeah. I hear it.
It's like when you allow something to vibrate with its natural frequency, then it's resonance. Resonance, we perceive resonance as music. We perceive resonance as
Music.
And what is resonance? When you allow something to vibrate with its natural frequency. For example, you like to do math. Okay? If we don't allow you to do math, then we are not allowing you to do something you like. If we ask you to play soccer, then will you look good, or will you feel good, or will you feel bad?
Feel bad, probably.
Yeah, feel bad because I don't really prefer playing soccer.
So why it took you half an hour to say that? Are you paying attention to the class today? You like to do math, and someone asks you to do to play, for example, soccer. Will you be feeling good or bad?
I don't really prefer sports.
Okay, and then you're not gonna, if someone asks you to do math, will you feel good or bad?
I feel good. I like math.
This is called allowing things to do what it likes to do. When you allow a musical instrument to vibrate with its natural frequency, then it creates resonance. If you do not allow, then what happens?
No sound.
No sound, yeah.
Then it creates noise. It doesn't create the resonance. Okay, let's go back. Now, did I give you some good idea about the waves?
Yeah.
Now, wave has properties and it has a characteristics. Wave has properties and characteristics.
Like reflection?
Yeah, that kind of thing. So let's write waves. First, we're gonna list all the characteristics and what? And their properties.
Yeah.
Characteristics and properties. Alright. Alright, number 1 is speed. Speed, right?
Yeah.
Speed is you can say velocity. And the velocity is lambda f. Did I prove that? Why it is lambda f?
Yes.
Okay, good. Number 2.
Oh, the SI unit is
SI unit is meter per second. Good point. SI. Number 2.
wavelength.
Wavelength is lambda.
Uh-huh.
The SI unit for lambda is meter. We talked about the lambda, right?
Yeah.
Number 3,
Period.
period.
Or T.
Period or T, and the SI unit is
S.
second. Number 4, frequency. Frequency F,
One
small
over-
f,
1/S.
1/s or hertz. If you prefer hertz. Number 5,
Amplitude.
amplitude. Amplitude and the SI unit
Meter.
is meter. Okay, now we're gonna write the properties.
Mm-hmm.
Number 1 is deflection. Number 2 is diffraction. Number 3 is
Interference.
interference or diffraction. I usually prefer diffraction, but interference.
Okay.
Then diffraction, I believe. I don't think they're
Number 4, diffraction and Doppler effect.
Doppler.
Diffraction,
I don't
And
know
then?
what that means.
Doppler.
Effect.
Alright, now we can understand everything today. Okay? How does that sound?
Yeah, sounds good.
Alright. Or you want to do it tomorrow?
No, I said let's do it today.
Yeah, let's all do it today.
Yeah.
Okay, sure. Alright, so let's first do the characteristic.
Okay.
Does that make sense?
Yeah.
Alright, so characteristic. Okay, let's first start with the speed. Does that make sense?
Speed.
Speed, yeah. So when something goes through the medium, what happened? Speed increase or decrease? The speed of light in the speed of light in the vacuum is what? We proved that. The speed of light in the vacuum is what? 3 times 10 raised to 8 meters per second.
79245.
And this man is responsible for that as well as Maxwell. Right?
Yeah.
Alright, now
And on glass, it's
Now this
about
is-
71,000.
this is in the vacuum or in the air, right?
Yeah.
But in the medium, water, would that be bigger or smaller?
Same.
Small.
Oh.
Is small. Go to the reference table. I'm going to tell you what page. We're going to find the speed of the wave in the water. Page number 5. There is equation n is equal to c over b. N is equal to c over b. We want to find the speed of what? The speed of light in the
Vacuum.
water.
In the water.
So give me the index of the water.
So 1.33.
Give me the index.
1.33.
1.33.
What pages?
Two.
Index for 1 point what?
33.
3. Page number 2, right?
Yeah.
Page number 2. Alright, now what do we need to find? Velocity of what? Velocity of the light in
Yeah.
the water, right? So
So
let's
V-
do cross multiplication.
V equals C over
Vn is equal to
C.
c. So v is equal
C
to
over N
c over n. So c is 3 times 10 raised to 8 meter per second
over
over 1.33, and that would be what?
3 times 10 to the 8 times.
3 times what?
3 times 10 to
10
the 8.
raised to 8 divided by 3 divided by 1.33 is how much?
2.25.
2.25
25.
times 10 raised to 8 meter per second. So is it less or more?
Less.
So speed of the light in the water is less, right?
Yeah.
Okay, why? Because it has higher index. The air index is how much? 1. Like vacuum. There is kind of vacuum. That's why most of the time we ignore the air.
Deflection.
So air is kind of vacuum. Index is 1. But water index is 1.33. So the speed of light
Much
in the
slower.
water, that's why light bend.
Yeah.
Light bend in the water, right?
And light slightly bends in the glass, but that's because it gets faster. It gets about 71,000, I calculate.
That's one of the properties of waves. We're gonna get to that in a second. But we just understand speed, right? Can you cross it out?
Yeah, we're done.
We are done. Alright, so one thing we know is speed of light in the vacuum is 3 times 10 raised to 8, which is constant. But the speed of light in, for example, water or glass is different, right?
Mhm.
We understand that,
It
right?
can vary.
It's always less than C. Always
Less than C.
less than C. Okay, so speed is done. Now we're gonna do lambda, period, frequency, and amplitude.
Yeah.
Alright, good. Now Few seconds ago, you asked me to draw a true cycle, right?
Sure.
Let's draw a true cycle.
Few minutes.
And you gave me how many meter?
10.
10 meter. And you gave me this amplitude is how much?
-5 to 5 meters.
5. Now, tell me what is the lambda?
Lambda is distance over cycle.
Lambda is hold on. Lambda is wavelength. Lambda is distance over
Cycle.
dist distance over
Number of cycles.
cycle. Now let's see cycle. This is one cycle. This is
2 cycles.
two cycle. And distance is
10 meters.
10 and cycle is 2, so 5. So lambda is 5. So can you say 5 meter?
5 meters.
5 meter. All right. Now, good. Amplitude. What is the amplitude? Amplitude. Is everything okay there?
Yeah.
Is it accurate?
Yeah.
All right. So amplitude is what? From equilibrium to the
Okay.
crest, or from equilibrium to the
Trough.
trough. So then, what is the amplitude?
5 meters.
5 meters. What a coincidence! I don't like this type of thing.
Wow.
All right, but it's okay, right? What is amplitude, by the way? Amplitude is energy. Amplitude
Energy.
is energy. For example, for sound
Loudness.
and for light,
Brightness.
for sound is loud. How do you spell it?
LOUD.
LOUD and brightness. Loudness or
Brightness.
brightness. For sound is loud. Does that make sense?
Yeah.
All right. So more amplitude means
More louder.
if it is
Sound.
more amplitude means
Brighter.
if it is
Lighter.
good. All right. Now give me another transversal.
Okay.
With how many cycle?
8 seconds.
How many cycle?
4.
You want me 4 cycle? You sure?
Yeah. Yeah.
Let's
Okay.
see. 1,
2,
2,
3,
3.
4.
You sure? You
Yeah.
want me to do 4?
Cut off the other. Yeah.
8 meter?
8 seconds.
8 seconds. Alright, now we're gonna find the period. Period is what?
Cycle.
What over what?
Seconds per cycle.
Second per
Cycle.
second per cycle. So how many seconds?
Eight
Let me
seconds.
erase that. We don't need that. How many seconds?
8 seconds.
8 seconds. And how many cycle?
4 cycles.
1, 2, 3, 4. 4. So how much is it?
2 seconds per cycle.
2 seconds. That means from here to here is
2 seconds.
2 seconds, right? 4 seconds,
6 seconds.
6 seconds,
8 seconds.
8 seconds. That's good. Frequency is
1 over 2 seconds.
frequency is cycle over
Seconds.
cycle over cycle. So what is cycle?
4 cycles.
Cycle is no. Cycle is
4 cycles.
no. We just can 4. Yeah, sure. 4
Cycles.
4 cycle.
Yeah, 4 cycles.
No.
Yeah.
No, that's not how we're gonna do it. So 1 over f,
So
1 over
T.
1 over 1 over
T. 1 over T.
1 over t. Yeah. So 1 over 2, so 0.5. 0.5 hertz. What does that mean? That means from here to here is 0.5. What does that mean?
Every second, half a cycle is complete.
Every second.
Half a cycle is complete.
Very good. All right. Now you understand all the characteristics.
Yeah.
You understand speed.
Speed.
What is the speed?
Uh,
Speed in the vacuum it is constant, as Maxwell said.
yeah.
But in the other than vacuum, like water,
Changes.
speed always less than c. Do you understand lambda?
Yeah.
What is lambda? Wavelength. Wavelength is crest to crest or trough to
Trough.
trough. Do you understand period?
Yeah.
Always second over
Seconds per cycle.
cycle. Do you understand frequency?
Yeah.
Frequency is always inverse of the,
Period.
which is if the period is 4, frequency is.
1 over 4.
If the period is 10, frequency is.
1 over 10.
If the period is 100,
0.01.
If the period is 100, frequency is 1 over?
100, 0.01.
Okay, good. Amplitude?
Amplitude.
What is amplitude? Amplitude is the energy.
Energy.
Energy. The wave carries the energy, right?
So that's why gamma rays have such high amplitude?
Oh.
That's right. Wave carries the energy, right?
Yeah.
So now, more energy means
More loudness or
if
more
it is
brightness.
sound.
Yeah.
More energy means brightness. If it is
Light wave.
brightness. So you understand all 5 characteristics.
Yeah.
All right. Now, what else?
Properties?
Can we do it tomorrow?
No.
No.
Every time you say tomorrow. I'm getting tired of you.
All right. So, properties. Properties. Let me put it first. I'm very tired.
Getting kind of tired of him saying, well, let's do it tomorrow.
Okay.
Properties.
Properties.
Number 1 is reflection. Number 2 is refraction. Number 3 is
Interference.
Oh, I'm gonna write it on the other side so that it can come this way. Is that okay, guys?
Yeah.
We don't need Maxwell equation, right?
No.
Properties. Number 1 is
Reflection.
reflection. Number 2 is
Refraction.
refraction. Number 3 is
Interference.
Number 4 is
Diffraction.
diffraction.
And Doppler effect.
Number 5 is
Doppler effect.
Doppler
Effect.
effect. Alright, now reflection is when incident angle is equal to reflection, angle reflection. On the other hand, refraction, incident angle not equal to interference. When 2 waves meet each other, then it creates interference.
Okay.
Interference are 2 types: constructive,
Destructive.
constructive, and destructive.
So, destructive, let me guess. It destroys
We'll
the wave?
we'll get to do that. Diffraction, the bending of
You
the
spelled
wave.
diffraction wrong.
How?
D-I-F-F.
D-I-F-F. Diffraction. Okay. Diffraction, the bending up the wave to overcome the
Barrier.
barriers. And Doppler effect.
Doppler.
Doppler effect. What is Doppler effect?
The frequency changes, increases or
Increase or decrease of frequency.
Depending
as
on
the source and the
what is it?
observer move closer
Move.
to each other.
Move with respect to the
Ground.
with respect to the source.
So
Okay. All right. So let's start with the what? Reflection. Can we?
Yeah.
So you have a medium. You have a medium. You have the what do you call this?
Incident rate.
Incident ray, right?
Yeah.
All right. How do you measure incident ray with respect to the normal? With respect to the
No.
this is called normal. All right.
Mhm.
Normal is always perpendicular with respect to the
Horizontal.
horizontal. Okay.
That's why it's called the normal force.
So this is what incident ray.
Yeah.
And law of reflection tells us that incident ray is equal to
Reflected ray.
refracted ray. So if this is 30 degree,
30 degree.
this is
30 degree.
30 degree. Then what is this one?
60.
60 and this one?
60.
60. Okay.
Are we going to have any?
Example? Sure.
Yeah.
Say mirror. Mirror is a good way of doing the example. So this is mirror 1, this is
Mirror 2.
mirror 2, let's say. And let's say something is a light ray hit the mirror, okay?
Okay.
What degree angle you think?
Not 30 maybe. It's an easy angle.
30, right?
Mm-hmm.
So you have to put a normal, and then what happened?
Reflected.
I'm gonna give you this one.
Uh-huh.
Let's say this one 130, and then I'm gonna ask you to find this one x. Okay?
Okay.
Alright, now let's find it. What do we want to find? X.
Okay.
Do we have a normal here?
Yeah.
Do we know this one?
60.
This is what we call.
Complementary angle.
No.
Incident rate.
Incident rate. What is incident rate?
60.
60. I have another color. Yeah. Green will be fine. Alright. So then, what is, if this is 60, what is this one?
60.
This is not drawn to the scale, you see that, right?
Uh-huh.
If this is 60, this is?
30.
If this is 30, this is 130, this is?
50.
20.
30, 130,
20.
20. If this is 20, what is this?
90?
70.
70.
70.
Oh.
And if this is 70, this is?
70.
Because this is angle incident, this is angle
Reflected.
reflection. So what is this?
70.
And then what is this?
20.
20.
Mm-hmm.
Oh.
Wow.
I get it.
Okay, good. So do you understand the reflection?
Reflection, yes.
Now what is it?
Refraction.
Reflection. Is that working?
Yeah.
Can you check? The big one. No, the big one.
Yep.
Okay. So now what are you going to do?
Refraction.
Refraction. Refraction we have to understand by Snell's law. By what? Snell's law. And
Oh, I
one,
thought you said snail's law. Not a snail.
Sine
is
theta
what
one?
it is.
yeah, S-N-E-L-L, Snell's law.
Snail's law.
N1 sine theta 1
Mm-hmm.
is equal to N2
Sine theta 2.
sine theta 2. And this,
You wrote sine theta 1.
oh, thank you.
Don't get people confused.
I'm a little tired. N1 is what? Medium. Right?
Mm-hmm.
Theta is the,
Incident rate.
well, I mean, the angle, right?
Yeah.
So this is medium, right?
Mm-hmm.
This is medium 1 and this is medium.
2.
This, let's say this is air and then let's say this is glass.
Okay.
Alright. Go to the page. What pages is it?
2.
Page number 2. What is the incident index for the air?
1.
And what is the index for the glass?
1.5.
1.5. I think let's crown glass.
Yeah,
Let's say
1.5.
crown glass, okay?
Oh yeah. Glass.
1.5. Alright, let's say what is this ray called?
Incident.
Incident?
Yeah.
Incident ray. What is this line called?
Normal.
Normal. Oh, we have to put normal like that. Why? Because this one will bend.
bend.
This one will bend. What degree you want me to call?
30.
Sure. Alright, now we know that this is glass, right?
Yeah.
So that the incident is gonna be greater than the refracted. Is that okay?
Yeah.
Yeah, because glass index
Very good.
is less.
Very good.
It's gonna be faster.
No.
It's gonna be slower. So velocity of
No.
1 is, this is velocity 1. This is velocity 1, right?
Yeah.
Velocity 1 is greater than velocity
2.
2. This is velocity 2, right?
Yeah.
Alright, and lambda 1 gonna be, lambda 1 is not equal to lambda 2.
But
However,
frequency
frequency 1 is equal to
Frequency
frequency 2.
2.
Frequency never changes. Is that okay?
Yeah.
Alright, we want to know this one. We don't know, but we hypothesize that what? We hypothesize that this is smaller than 30, right?
Yeah.
Is that what it says?
Mm-hmm.
This is smaller than
30.
30. Alright, let's do it. N1 is what?
1.
Sine
30.
theta is 30. Is equal to N2 is what?
1.5.
1.5 sine theta 2.
Uh-huh.
Right?
Yeah.
Okay, I think I can do
Okay,
it.
So theta is equal to?
19.5.
No, hold on.
No.
Theta is equal to
You
1.
actually have to solve.
Oh.
When do I want to
I get
1.5 sine theta 2 is equal to sine 30. So,
isolate theta 2.
so sine theta 2 is equal to sine 30 over 1.5.
5.
So sine 30 1.5 is how much?
Well, half times 1.5.
Half times
1.5.
1.5. And that is how much?
So 0.333.
0.33. Theta 2 is equal to inverse sine
So yeah, 19.47.
19 plus than 19.5.
Oh, that's what I said.
So is this 19.5 degree?
Yeah. And that's less than 32.
So is this so
I
incident?
actually got 19.2.
Wow.
Alright, that's fine.
It's 19.2 with the exact
That's
frame
fine.
last thing.
Alright, so this is 30 and 30 is less than.
19.
Is that true?
Yeah.
And now you understand the deflection?
Mm-hmm.
Alright. Good. Now what is it?
Interference.
Interference. Interference is pretty easy.
So, constructive and destructive.
So interference.
This is fun.
Interference. What is interference? When two waves miss each other, right?
Yeah.
Constructive,
Destructive.
and destructive. Constructive. An example. A, B. So then, what would be the constructive wave?
Their combination.
A plus B. Does that make sense?
Yeah.
And destructive, you're gonna see right here, different color. This is A, and this is
Under.
B. A is this way, B is
That
this
means
way. So the destructive will be
nothing.
A plus B because they cancel
Out.
each other. Does that make sense? So you understand the interference?
Yeah.
What is the next one?
Diffraction.
Diffraction.
So, is it like when Isaac Newton put the prism in his eye and refracted white light?
Wow.
The light diffraction we're gonna do next time. Okay, this is sound. This is longitudinal. This is where we are talking about the longitudinal diffraction. Okay.
Yeah.
All right. Let's understand what it is. Diffraction. Diffraction is what? When a wave try to overcome the barrier. Okay. Let's use the light one. I'm sorry. Let's use the water one. Okay.
Water diffraction.
So let's call this is water, right?
Yeah.
And let's put a barrier. Let's
It's
put
like
a
ripples in a pond?
let's put a barrier.
Like maybe the barrier is a rock that
Barrier
somebody
can be.
threw into
That's
a
right.
pond?
That's okay. It looks like that, right?
Yeah.
It does not show much diffraction. Is because why?
Well, it's just a.
Because the wavelength is
pretty big.
the pretty bigger than
The
the barrier is pretty big.
Yeah.
Barrier is
Pretty big.
pretty big.
Easy to
But-
overcome.
Yeah, but a small barrier makes bigger diffraction. A small barrier makes
Bigger
bigger
difference.
diffraction. Okay, let's look at other way. This is water. This is barrier. Right?
Mm-hmm.
So this how it looks like, right?
Yeah.
Now we're gonna make the what is small?
Extremely small barrier.
Extremely small barrier. And let's see how.
Or gap. Extremely small gap.
Extremely small gap. I'm sorry. Yeah. Small gap, right?
Yeah.
So the bigger gap means less. Big
Diffraction.
gap
Small
is less.
diffraction.
less
Diffraction.
diffraction. The small gap means
Big diffraction.
big diffraction. Big diffraction. Do you see the diffraction?
Yeah.
Alright, now last one. What is it?
Doppler effect.
Doppler effect. Okay, so Doppler effect is increase or what is Doppler effect?
The increase or decrease of frequency.
Doppler effect. The
Increase or decrease of frequency.
increase or
Of
decrease
frequency
of frequency
as the source and the observer move,
as the source move to each other. As the source
and observer move to each other.
or observer
Move to each other.
move to
Each other.
each other. Alright, let's draw the picture.
Mm-hmm.
This is track. This is source. Why it is source?
That's what the sound
because
is.
this let's say it's honking, right?
Yeah.
This is, let's say this is you.
Mm-hmm.
This is Albert, right?
Yeah.
And this is
I.
Isaac. The car moves to what direction?
Isaac.
Isaac. Let's put them closer then, because I'm a little tired. So let's put them closer.
Okay.
Don't worry, the track not gonna hit you. Okay. So then the frequency. Which way the frequency increases?
In my direction.
The wave source moves to the
Oh,
observer.
observer.
Observer number. This is Isaac. This is Albert. Alright. So the source moves to the observer number 1. Observer number 2. Alright. So this, you said this frequency would be
Increased.
increase, and this frequency is
Decreased.
decrease.
So high pitch, low pitch.
High pitch. Okay, good. If you wanna say high pitch, low pitch. Okay.
Yeah.
Now how can you show that? This is how I'll use it.
Draw the sound wave.
Draw the frequency.
Wow. It gets less dense as you go in my direction.
Which way show more the frequency?
Observer 1.
So this is high frequency.
Uh-huh.
This is
Low frequency.
low frequency. Right? High pitch,
Low pitch.
low pitch. Okay.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.